Hi students, how are you? I hope all you are fine, very fine. Today we are going to discuss the next chemical properties of haloalkanes, and that is the halogen exchange reactions. My name is Ritesh Mishra. Let's start the topic. See students, the question is why we need the halogen exchange reactions. Is it not possible directly to prepare from alcohol to iodide? Yes, indeed it is possible. Because already we have done that alcohol react with that red phosphorus in the presence of I2, means PI3, and then the form alkyl iodide. But again I am asking you that alcohols form alkyl iodide in the presence of PI3, means in the presence of PCl5 or PPR, like that, substances like that we have prepared them. But question is that how is it possible? See here, ROH, if I take the HI and if I take the HI excess, correct? So if I take the HI excess, you know what happens? It will form the alkyl iodide, but since we have taken the HI excess, so again the HI will react and it form the alkane plus I2. This I2 is reduced form. This I2 is reduced form. Reduced form. Correct? Understood? So when we take the ROH with the HI, because whenever we take the HI, either the alcohol we have to take the reflex form, and HI around more than 50%. Always we take more than 50%. So what happens? Alkyl iodide is formed, or you can take the H3PO4. Alcohol react with HI in the presence of or Ki. When you take the Ki, we take the H3PO4. So the question is how and when we form directly. Is it possible to form directly? Because when we go directly, we are getting the alkene. So therefore we need a halogen exchange reactions. So through halogen exchange reactions, we can prepare the alkyl iodide. That is called finkelstein reactions. So finkelstein reactions, halogen exchange reactions. Why we need halogen exchange reactions? I hope you understood. Because when we take directly, alkane is formed. Not a reaction will not stop at alkyl iodide. So in the Finkelstein reaction, when we take the alkyl chloride or alkyl bromide, because from alcohol to alkyl chloride is very easy. That the PCl5 or SOCl2 you can take similarly. Bromine is easy. So now when we take that sodium iodide in the presence of acetone, now see why we take sodium iodide in the presence of acetone, because sodium iodide will be soluble in the acetone. Since it will be soluble in the acetone, hence it will not form the precipitation. Otherwise, if you take the sodium bromide or sodium chloride, that will not dissolve in acetone. That will not form the precipitation. That will not dissolve means, if will not dissolve means will form the PPT and the reaction will be reversible. Again I repeat it. If you don't take the sodium iodide, instead of sodium iodide, if you take this sodium chloride or sodium bromide, will not dissolve with acetone, and that will form the precipitations and which will form the reversible reactions. Correct? Now? So to stop the reactions to be reversible, we take the sodium iodide. Correct? So now what will happen? Then alkyl iodide is formed. And as you know, this is the whole step is, what is step? SN2. Of course the inversion will be happen. So suppose we have taken here what, chlorine and CH3, right? Or anything you can take here, right? Benzene and or H. What happens when we take sodium iodide in the presence of acetone? So that reaction will be the, here is iodine CH3 H and benzene. So these things will be happen, inversion will form, correct? Now there is one more part is that Swarts reactions, because why we need the Swarts reactions, just to understand. But one thing I am sure you understood, sodium chloride, first you prepare from alcohol to alkyl chloride or alkyl bromide, then we have to go to the alkyl iodide, because when we take Hi, that will form the alkyl iodide and reaction will not be stopped there. So since we have taken the Hi excess, so that will form the alkane and I2 in the reduced form. To stop this process, we form first alkyl chloride or alkyl bromide, which will react with sodium iodide in the presence of acetone and then form the alkyl iodide. And if I take the sodium chloride or sodium bromide, that will not dissolve in the acetone, and that will form the precipitations which will form the reaction reversible. Done? So that is the process, that whole process will be happening. Now next part is that how to form the fluorine. See, we form the fluorine by Swarts reagent, fluorinating agents, fluorinations. So we go to that Swarts reagents, and why we take the metal D block chlorides, we understand here. And what will happen when the AgF will take in the presence of water, then what step we follow, SN2 or SN1? All these things we understand here. See, now the point is here, if we take that fluorine, so first of all you understand one thing. As you know, the fluorine is not a good leading group, even though it is not a good nucleophile. So how is it possible when we have alkyl chloride or alkyl bromide, so and you are taking the AgF, correct? Yeah? So AgF, metal fluoride, D block fluorine is the Swarts reagents, correct? Yeah? So either you take the COF2 or SbF3 or Hg2F2, correct? These are all the Swarts reagents and the fluorination reagents. This is called fluorination reagents or Swarts reagents. The main point is that Swarts, although Swarts reagent is SN2 process, students, this is the SN2 process, okay? Because one halogen exchange with the other halogens, correct? So that's the SN2 process. Now question is that, sir, if the metals, in the D block metals, what do that? D block metals give the more power to the fluorine, which will then act as a good nucleophile as compared to chlorine or bromine. As you know that iodine is a very good nucleophile, then the chlorine, then the bromine, then the chlorine. Fluorine is a very poor nucleophile. But if you don't take the D block metals, that will not form the good nucleophile. So all the D block element enhance the fluorine to be a better nucleophiles. So that is the reasons we take the D block elements. Now the point is that, sir, what will happen when we take the AgF in the presence of water? If you take a simply AgF in the presence of acetone or any other polar aprotic solvents, right? So that will form the SN2 process. So usually Swarts reaction is because all halogen exchange is SN2 process. But my question is, what will happen when AgF in the presence of water will take as a polar protein? Interestingly, students, it will go into the SN1 reactions. So what happened? The first alkyl cations will form and then the fluorine will attack. But it's rarely will happen. Usually Swarts reactions will take in the presence of polar aprotic solvent, not a polar protein. But if water will take, because AgF only in all the Swarts reagents, only AgF is soluble in the water. So the question is, sir, if water will take, then what will happen? That will follow the SN1 path. Otherwise, Swarts reaction is SN2 paths. Done? So I hope you understood this. This is a very small part. This is method of chemical properties we have. So method of preparation we have completed now. So next we will go to that chemical properties of alkyl halides. I hope you understood. If you understood, students, please like, share and subscribe. Thank you.